Hi, welcome to today's session on AhaGuru question types for JEE and NEET. So every week I will introduce one very important question type that will come up in JEE or NEET. So we will take up the previous year question papers, look at the same kind of question that gets repeated again and again, and I will tell you how you can approach that question. Today we are going to focus on Coulomb's law. Now, Coulomb's law has many different types of questions that will be asked in the JEE and NEET. We are going to focus on charged pendulum bobs. There are different variations of this charged pendulum bob question that will be asked in the JEE. Okay, so let us start by looking at what kind of questions are asked. So look at this question that appeared in the JEE in 2021. Two small spheres, each of mass 10 milligrams, they are suspended from a point, all that is given, right? So basically you have a pendulum with a bob. The bob is charged. You have two of these, and so they are going to move like that, right? So they are going to basically form like an angle between them like this. So they are equally charged, they repel each other to a distance of 0.2 meters. The charge on each of the spheres, it is given in the form of a by 21 into 10 to the power of minus 8 coulombs. Find the integer nearest to a. So that is the first question. We are going to look at this question. It's a very simple, straightforward one. Now this question, a lot of people know how to do. Okay. But look at this variation that appeared in 2010. Two identical charged spheres are suspended by strings of equal length. Similar kind of a question. The strings make an angle of 30 degrees with each other. When the same thing is suspended in a liquid of density 0.8 grams per cc, the angle remains the same. So in air, they make a particular angle, and you take the whole system and put it inside a liquid, the angle remains the same. Okay, using this, they want you to find the dielectric constant of the liquid. Now this is not looking like that question, right? Actually, it is the same question, except here we want to find the dielectric constant, but the approach is going to be the same. The same principle is basically going to be used. Okay, we are going to look at tan theta for both of these cases, and you will see that it is exactly the same question. Now let us look at this one. This appeared in 2011 in JEE, and the same question was repeated in NEET in 2016 as well. Okay, two identical charged spheres suspended from a common point. Look at this. It's exactly like the previous two questions, right? So you have basically two pendulum bobs. Okay, they are charged. The strings have length L. So what's going to happen? Since they are charged, the pendulums are going to basically swing to an angle. Now, what happens here is because the charge starts to leak, the charge begins to leak from both the spheres at a constant rate. As a result, the charges, once the charge leaks, that means the charge is reducing, right? So therefore, they will start approaching each other. They will start approaching each other with a velocity v. Then we want to find how is the velocity v related to the distance x between them as they are coming closer and closer to each other. So these are three different questions. They look different, but all are based on the same principle that when you have charged bobs, okay, hanging from a string, the strings will basically swing away from each other because of Coulomb repulsion. So we're going to learn how we can basically approach each of these questions. So for this, we need to understand what happens when you have two charged objects that are stuck to a point, right, tied to a point by connected by strings. So let us look at that by looking at this repelling balloon experiment. Okay, so you have these two balloons. Both are equally charged, negatively charged. They are both tied to this point. Obviously, they won't remain like this. The moment I release it, this negative charge is going to push that negative charge is going to push this, and so they are going to basically start moving apart like this. So they are going to move apart like this. And then they will come to rest at this position where they make an angle with each other. They make an angle with each other. Can we find the relationship between the angle that they make and this force, electric force? We can do that. Okay, so if I say that this distance is x, right? This force between them will be k q1 q2 by x square, k q1 q2 by x square. Okay, and suppose I say let me drop a vertical line. This angle theta and this angle theta, they are going to be equal because these length of the strings are equal. So this angle is theta, both the angle with vertical. So between the two strings, the angle is 2 theta. This angle is 2 theta. Okay. Now the question is, why is this balloon staying here? There is one force. If there's only one force, it can't stay here. But there's also a gravitational force mg acting on both of these. There's going to be a tension force basically that the string is going to exert on these balloons. So you're going to have mg acting on both of these balloons, and you're going to have t acting on both of these balloons. Now this force together makes this balloon in equilibrium. Same way, this force together makes that balloon in equilibrium. The sum of these three forces is going to be 0. Now the usual way people try and solve this is to say, hey, let me take this t and let me resolve it into a vertical and a horizontal component. I will do that here. Okay, so basically I'm going to say this is t. If I look at the vertical component of t like this, that will be t, well, this angle will be theta, so it will be t cos theta, and this direction it will be t sin theta. And so f and t sin theta must cancel, t cos theta and mg must cancel. So you can write two equations, t sin theta equal to f, t cos theta equal to mg, and you can then solve. You can do that, but there's a much neater way which I like. I call this the force triangle approach. So what you do is that you recognize that this force plus this force plus this force, vector sum must be 0. So just simply place them one after the other. mg plus f plus t must add up to 0. So let me bring mg down. Let me take this f here. So mg plus f plus t must come back to the starting point. And you see that this is a nice right angle triangle. And what is this angle? T is along the rope. So it makes an angle theta with the vertical. So that this mg is vertical. So this angle must be theta. This angle must be theta. So you see, this is a nice right angle triangle. And so this angle is theta. Opposite side is f. Adjacent side is mg. What is opposite by adjacent? Tan theta. So tan theta is f by mg. Tan theta is f by mg. Right? So this relationship we can very easily derive using this force triangle approach. And remember that the force between these two charged particles will be k, q and q2 by x square. K is Coulomb's constant. X is the distance between these two. So we are going to use what we have learned now to solve these JEE questions. Okay. Now, of course, we are going to use this as the basic foundation. We also have to read each of these questions carefully because each of these questions also involves a slight variation. Let us now look at this question that appeared in the JEE in 2021. Two small spheres, okay, these ones, both of these have mass 10 milligram, not gram, not kilogram. SI unit is kilogram. Remember, these have mass 10 milligram. So milligram to gram conversion, you have to multiply by 10 power minus 3, but gram is not SI unit. So kilogram is SI unit. So gram to kilogram, another 10 power minus 3. So milligram to kilogram, you have to multiply by 10 power minus 6. Please keep that in mind. A lot of people make this mistake. Okay, so these two have mass 10 milligram each. They are suspended from a point by threads 0.5 meters long. So this is 0.5 meters. This thread is also 0.5 meters. Now, because of the mutual repulsion, they are equally charged. Okay, so they repel each other to a distance of 0.2 meters. So from here to there, 0.2 meters. So this is 0.2 meters. So this will be 0.1, 0.1. So let me write 0.1 meters, 0.1 meters. So total distance between them, 0.2 meters. The charge on each of the spheres is given in this form. A by 21, 10 to the power of minus 8 coulombs. Find the integer nearest to A. This is an integer type question. So you have to rewrite the answer for Q. You have to find Q and rewrite it in this form and then look at A and look at the integer nearest to A. G is 10 meters per second square. Now you know that these two, they are going to have a gravitational force pulling them down like this, right? So this will be mg. I'm using capital M because here this mg is milligram, this is mass into g. So this also has mg force, gravitational force. And of course, this is going to repel that with a force F, and that is going to repel this with a force F. And that's all? No, you're also going to have a tension force T this way. And so these three forces keep this Q in equilibrium, right? mg plus F plus T must come back to the starting point. Why? Because these three forces are basically going to add up to 0. So we can do a vector addition. We can say mg plus F plus T must come back to this starting point, right? Vector sum must be 0. And this angle, if it is theta, this angle will be theta. Why? Because this is along the rope. This is the vertical. So this angle is theta. This is 90 degrees. So we can write tan theta is F by mg. So I can write here tan theta is F by mg. What is F? F is Coulomb force. K Q1 Q2 by 0.2 whole square. So we can directly write that. So let me write the values. F is K Q1 Q2, which is Q into Q, so Q square, by distance between them. Don't use 0.1. From here to there, what is the distance? 0.2. 0.2 into 0.2. So 0.2 square. Okay. This is F. mg. What is M? M is 10 milligrams. Milligrams to kilograms. Remember, kilogram is a unit, not gram. So it is 10 into 10 power minus 6. A lot of people will write 10 into 10 power minus 3. Be careful with it. So the next step, mass M is 10 into 10 power minus 6 kg. Always use SI units. Into G. G is 10. Now this will help me solve, except I don't know what is tan theta. How do I find tan theta? Tan theta is this side, 0.1 by this side. How do I find this side? You can do root of, right? You can say Pythagoras theorem, root of 0.5 square minus 0.1 square. That's going to be a little long and cumbersome. You don't need to do it. Anyway, they're asking you integer nearest to A. So what I'm going to do is to say, let us think about sine theta. Sine theta, opposite by hypotenuse, is 0.1 by 0.5, 1 by 5, 1 by 5 is 0.2. This is quite small. Sine theta is quite small, right? So that means theta is small, and if theta is small, sine theta is approximately theta, and tan theta is approximately theta. So we can say that tan theta is approximately 0.2. Why? Because tan theta is approximately the same as sine theta. So I'm going to use this. I'm going to say this tan theta is 0.2. Then I can write q square, just cross multiply, you will be able to figure that out. So q square is 0.2 into 0.2 square into 10 to the power of minus 4, right? You have 10 into 10 into 10 power minus 6, so that is 10 power minus 4 divided by 9 into 10 to the power of 9. 9 into 10 to the power of 9. But I have a 0.2, right? I don't like 0.2 here. So what I'm going to do is when I want to take square root, this is nice to take a square root. It has a nice perfect square. It has a perfect square. This has a perfect square. This has 10 power 9. So it's a good idea to multiply this by a 10 and multiply this by a 10. So then I get 2. So when I take square root, at least I'll get root 2 instead of root of 0.2. So what is q? Root 2. This is going to give me 3. This is going to give us 0.2. No, it's not root of 0.2. Remember, 0.2 whole square root will be 0.2. And then this is going to give 10 power 5 and that is going to give 10 power minus 2. So 10 power minus 2, 10 power 5. So together this is 10 power minus 7. And if I take that 0.1 from that 0.2 and put it there, it will be 10 power minus 8. You want 10 power minus 8. So let me take this point from there and put it here and write this as 2 root 2 by 3 into 10 power minus 8 Coulomb. Is this how you want it? No, you want it by 21. You don't want it by 3. You want it by 21. How do I get it by 21? Multiply by 7, you will get 21. That means numerator also you must multiply by 7. So I can write Q, if I multiply by 7, numerator and denominator, this will be 14 root 2. 14 root 2 by 21 into 10 power minus 8 Coulomb. So this quantity is A. So A is 14 root 2. What is 14 root 2? 14 into 1.414, right? So this is approximately, right? 14 into 1.414 is 19.7. Now what is the integer nearest to A? Integer nearest to A is 20. So the answer to this question, answer is that the integer is how much? 20. A is 19.7 and so the integer closest to A, the answer is 20. So I hope you have understood how to solve this question. Basic idea is that you draw this force triangle, use that to write the main equation. Tan theta is F by mg. The rest of the calculation becomes quite straightforward. Let us now look at the next question. Here is an interesting variation of the charged bob question that appeared in the JEE in 2010. Two identical charged spheres are suspended by strings of equal lengths, like this. The strings make an angle of 30 degrees with each other. So this whole angle is 30 degrees. So 2 theta will be 30 degrees, theta will be 15 degrees. Now that is an air. Now you take the same thing and when you suspend it in a liquid of density 0.8 grams per cc, what happens? The angle remains the same. Angle remains the same. But wait a minute. Once you put it in the liquid, won't there be a buoyant force? Shouldn't the angle change? There will be a buoyant force, but the liquid is also a dielectric medium and so the electrostatic force, the Coulomb force will also become smaller. So both of these together, the effect is that the angle remains the same. Okay, that is the information given. If the density of the sphere is 1.6 grams per cc, find the dielectric constant of the liquid. So let us say that the dielectric constant, we'll call it capital K. Small k is Coulomb's constant, dielectric constant, capital K. Density of the sphere, we will call it sigma. Because it's a sphere, we will call it sigma. For the liquid's density, we will call it rho. We'll call it rho. Okay. So first let's think about this. You know that there is going to be a repulsion like that, repulsion like this here. And usually what do? We say, okay, this is mg, this is that force F, and this is T. This angle is theta, 15 degrees. Tan theta, F by mg. Tan theta is F by mg. So let me write that down. Tan theta is F by mg. Okay. Here, I will also have a buoyant force. So my vertical force will no longer just be mg. So my vertical force will be mg minus buoyant force, which I will call as Fb. F buoyant. And the force between these two, right? This is pushing that and that is pushing this. How much force? I will bring that force down here. Okay. It's the same force here. But it won't be F. Here you have a force F. What will be the force once you keep it in a dielectric? F by K. F by K. This force is Coulomb's constant into Q1, Q2 by R square. R hasn't changed. The distance hasn't changed. If this distance is X, this distance is X. Why? This is L, this is L, this is the same angle. Angle hasn't changed. So this distance remains the same. So if the distance is the same, what will be the force? Think about it. So the force in a medium, F in a medium, is F in vacuum divided by K. You know this, right? 1 by 4 pi K epsilon naught. So instead of whatever you had usually, this was 1 by 4 pi epsilon naught, Q1, Q2 by R square. Exact same formula, same R, same Q, everything else is the same. Except you have K epsilon naught. So the force here is F by K. F by K. Okay? So that's K is what we need to calculate. This force is F by K. I will put it here. I'll write F by K. Okay? And this is the tension. Will it be the same tension? No, it will be a different tension. T1. But the angle is the same. This force is different. This force is different. This is T1. That's also different, but the angle is the same. But then I can write tan theta is F by K divided by this. Yeah, we can do that. So we can also write F by K divided by mg minus Fb. Same tan theta. What is tan theta? Tan 15 degrees. I don't even need to know what it is. This is it. Now this is the equation. Once you write it like this, you can cancel the F. You can cancel the F. Right? So let me bring it down a bit. You can write the K here. You can take the K there. So if I cross multiply, I can write K. F and F cancels. So bring the K there. Bring the mg there. It is mg by mg minus Fb. You've got the answer. Dielectric constant, this is the answer. But wait. Mass of the spheres not given. Fb, what is buoyant force? Not given. Those are the things to find. What is buoyant force? Buoyant force will be density of the liquid into volume, weight of the liquid displaced. What will be the weight of the liquid displaced? Suppose this one has a volume V, right? The volume of the liquid displaced will be V into rho, which is the density. So the liquid has density rho. Let us say that the solid has density sigma. So you can say rho into V will be the mass of the liquid displaced into G. So buoyant force, let me write that here. Let's clear up some space and write some information. Buoyant force will be rho of the liquid, volume of the sphere into G. Clear? Mass of that sphere is sigma into V. So mg will be sigma Vg, Fb will be rho Vg. So if I just substitute, so this will be sigma Vg. This is the density of the sphere, volume of the sphere G. This also is sigma Vg minus density of the liquid, volume G. So Vg we can cancel. So we get sigma by sigma minus rho. So what is K? Sigma by sigma minus rho. What is sigma? Density of the sphere, which is 1.6. Everything now I can write it in terms of grams per cc because everything is a ratio, so you don't need to worry. Sigma is 1.6 minus rho is how much? 0.8. So 1.6 by 0.8, right? 1.6 minus 0.8 is 0.8. 1.6 by 0.8, 1.6 by 0.8 is 2. Not 0.2, just 2. This is 2. Okay? So let me erase that and write it. So this is 2. K, and it is a number, right? Ratio of grams per cc. So no units, K is 2. So find the dielectric constant of the liquid. Answer is 2. K is equal to 2. Notice this question, actual calculation was quite easy. You have to remember mg minus Fb and this is F by K. So that is the important idea. Once you understand it, then you can solve it. It's a nice variation of this charged bob question, right? Charged bobs that are repelling, like a pendulum, they repel, right? So that same question, this is a very interesting variation of that question. because the angle is the same, the distance remains the same. This distance is the same as that. So Coulomb force should not have changed except for the dielectric. That's why you can use F by K as this force. That is very important. Okay. So this question, I hope you have understood how to solve. Let us now look at the next variation of the charged bob question. Here is another interesting variation of the charged bob question. Okay, this appeared in the JEE in 2011. Again, it was repeated in NEET in 2016. Exact same question was repeated. Two identical charge spheres are suspended from a common point by two massless strings of length L. They are initially at a distance d, which is much smaller than L. So that means this angle theta is quite small, right? Because this distance is much smaller than L. That means this angle theta is very small. So the charge begins to leak from both the spheres at a constant rate. That means dq by dt is a constant. dq by dt is a constant. Okay, it's leaking from both the spheres at a constant rate. As a result, the charges approach each other with a velocity v. Then, as a function of the distance x between them, what is the relationship between v and x? That is the question. So let us say at any given time t, let us say that the distance between them is x. So v will basically be dx by dt, right? It will be dx by dt. So this will be x by 2, that will be x by 2, x by 2, x by 2. Now this charge is going to push this charge like that, and there's going to be a mg force down, right? Gravitational force mg. And so this is going to push that, this is going to push this, that instead of drawing it there, I'm going to draw it here. We know that this is F, Coulomb force, and then this tension T, right? We have already done this many times. So it has to come back to the starting point, forming a nice right angle triangle. This angle is theta, because this force T is going to act along the rope. So this angle is theta. Theta is small, theta is small. So if theta is small, tan theta is approximately equal to sin theta. Okay, so sin theta is x by 2 by L. So whenever we want tan theta, we can say F by mg is tan theta, which is also equal to sin theta. So we can write tan theta is F by mg. F by mg. But tan theta is approximately equal to sin theta. So let me write that here. So let us say tan theta is approximately sin theta, which is how much? Well, think about this. This is right angle. So opposite by hypotenuse. X by 2 by L. So x by 2L. So that is tan theta. So I can then say this is x by 2L. But what is F? F, that is a Coulomb force, right? This force F, that force F, how much is it? K Q by x square. So I can directly write that here. K Q, so K Q square by x square. Now that is F. Mg is still there, so let me put Mg. Okay, so I've got a nice relationship between x and q. Let me bring all the x's to one side, q's to one side. Okay, so let us say keep the q there. Let's bring all of this here. So mg by 2l k. So let us write q square. Q square is mg comes here. X into x square into x will be x cube. So that I'll write here x cube. Okay, k comes down. 2l. So 2kl. 2l into k, so 2kl, right? I think I brought everything down. Yeah. So I've got q square like this. So this tells us that q is a constant times, right? What is the square root of this? X to the power of 3 by 2. So it is root of mg by 2kl. We don't need all this. X to the power of 3 by 2. So this is the relationship between q and x at any given instant. So if I now differentiate this with respect to t, I'll get dq by dt, which is a constant. dq by dt is a constant, right? So if I differentiate with respect to t, I can write dq by dt How do I know it's a constant? Because they are leaking charge at a constant rate, slowly leaking charge at a constant rate, dq by dt. So that is this constant times, so it will be this constant. This is a constant, right? Times 3 by 2 x to the power of 3 by 2. If you differentiate, what do you get? 3 by 2 x to the power of 3 by 2 minus 1, which is 1 by 2. X to the power of 1 by 2. Into dx by dt. Don't forget that. This is v. Now this is a constant. Why? Constant rate. This is a constant. This is a constant. So that means v into x power half is a constant. And so that means dx by dt, which is v, is this constant divided by this constant into x power minus half. So I can say some constant into x power minus half. So v is proportional to x power minus half. V is proportional to x power minus half. So I hope you have understood this, right? So basically again we use the same idea of drawing the force triangle and F by mg is tan theta and make certain approximations for tan theta to solve a question like this. Of course, little different here because dq by dt is constant and so dx by dt is v. So we have to rewrite dx by dt in terms of all of this constant, x to the power of minus half. And so we get v is proportional to x power minus half. So I hope you have understood how to solve this type of question where you have two charges which basically are connected to strings. So you actually get a swinging pendulum like that. So questions like this, you should know how to approach them using Coulomb's law. Now, of course, I have done here one type of question, right, based on Coulomb's law. That there are many, many more types. And so in this course, right, I have done a complete chapter course for electric charge and field. So this chapter course, right, we call this a micro course. This has 114 concepts and solved example questions where different types of questions I have solved that will appear in CBSE, ICSE, JEE and NEET. So if you go through this course, you will understand all of the concepts from this chapter and you will also understand how to solve every type of question. So my strongest recommendation is that you go through this course carefully. You will be able to then solve every type of question from this chapter. You can download this course by downloading this Android app from the Google Play Store, AhaGuru Courses app. You can go and search on Google Play Store and download that, and then you can get the course from there. Or you can go to this website, ahaguru.com/microcourses, and you can look at this course and you can basically take this course. And if you use this code, YouTube, right? So YT15, you will get an additional 15% discount on this course. So please do take this course and try out all of the questions from that course. You will find that it's extremely useful for your exams. So all the best. See you again next week with another type of question.